So here's our first center of mass example. We have three particles of masses m1 equals 1.2 kilograms, m2 equals 2.5 kilograms, and m3 equals 3.4 kilograms form an equilateral triangle of edge length 140 centimeters. Where is the center of mass of this system? So for something like this, what we need to do is draw a coordinate system, and the easiest way to do this is to put those masses on, one's going to go on the origin and then another is going to go on that x-axis, so that the y coordinates for both of those and then also the x coordinate for one of them also is going to be 0. It makes our math a little bit easier, and I'll show you what I mean by that. So here's our coordinate system. I'm going to put m1 at the origin. So we have m1 here. I'm going to put m2 on that x-axis, and then we'll put m3 up here. Now we know about that because this is an equilateral triangle, all of the sides are going to be the same. So that means all of those are going to be equal to that 140 centimeters or 1.4 meters. And you can keep it in centimeters. It's totally fine. You'll actually get a centimeters for your answer, but yeah, it doesn't really matter here. This is one of the rare chances, rare thing where what times you can actually keep it in centimeters, because you'll just get your answer in centimeters. Now let's take x and y separately here. Okay, so what I mean by that is I'm going to find the x coordinate of the center of mass first and then the y coordinate of the center of mass. Now if I'm looking at the x coordinate, I can see that my x coordinate of mass 3 is going to be smack dab in the middle of that mass 1 and mass 2. Does everyone see that? So if we look at mass 3 right here, the x coordinate of that is going to be right here, which is going to be that 0.7 meters or 70 centimeters. So if I'm looking for the x coordinate of the center of mass, we'll just keep it in purple, I get mass 1 times x position of 1 plus mass 2 times x position of 2 plus mass 3 times x position of 3, all divided by mass 1 plus mass 2 plus mass 3. So for our center of mass x coordinate, we get mass 1, which is 1.2 kilograms, but look, our x coordinate of mass 1 is 0 because it's on the origin. So I get 0 for that first term right there. And then mass 2 is 2.5 kilograms. And then our x coordinate for mass 2 is 1.4 meters. Plus mass 3, which is 3.4 kilograms, times the x coordinate for mass 3, and that is 0.7 meters, or 70 centimeters, all divided by the total mass, 1.2 plus 2.5 plus 3.4. So for our x coordinate of the center of mass, 2.5 times 1.4 plus 3.4 times 0.7. We'll divide that all by the quantity 1.2 plus 2.5 plus 3.4. And we end up getting 0.83 meters or 83 centimeters for the x coordinate. Now let's look at the y coordinate. So our y coordinate right here, let's do that in green. We can see that the y coordinate for both mass 1 and mass 2 is going to be 0 because they're both located on that x-axis. So that means y1 and y2 will both be 0. Now this right here, we need to find the y coordinate for mass 3. Now in order to do that, we can just use the Pythagorean theorem. So we know that that triangle right here, I have 70 centimeters here. I have 1.4, sorry, let's keep it in all in centimeters, 140 centimeters here. So I need to know what this y3 is right there, and my triangle is not drawn to scale. So I'm looking at this triangle right here in order to find the y coordinate for mass 3. So I know 70 squared plus y3 squared is going to be equal to 140 squared, because a squared plus b squared equals c squared. So if I take y3 will be the square root of 140 squared minus 70 squared. And I end up getting 121.24 centimeters for that one. So now we can use our center of mass equation in order to find the y-coordinate of the center of mass. So we get y-coordinate of the center of mass will be equal to mass 1 times y1 plus mass 2 times y2 plus mass 3 times y3 divided by mass 1 plus mass 2 plus mass 3. Again, the y-coordinate of both mass 1 and mass 2 is 0, so both of those terms become 0. So we get y center of mass equals 0 plus mass 3, which was 3.4 kilograms, times the y-coordinate of 3. Let's do this in centimeters. Why not? We get 121.24 centimeters. And then divided by the total mass, which was 1.2 plus 2.5 plus 3.4. Let's just do that. 1.2 plus 2.5 plus 3.4 is 7.1. So we'll divide that by 7.1. And we end up getting 58.06 centimeters for that. So our answer here ends up being that the coordinate, the center of mass of the system, or our position vector for the center of mass. Let's do this in unit vector notation. Why not? We have, for x was 83 centimeters, so we get 83 centimeters I hat, and then plus 58.06 centimeters j hat. You can also do it like this. Means the same thing.